Our next speaker is, I'm very proud to present, is Dr. Mark Turner. He's the founding director of Cognitive Science Network, so he holds a faculty position at the Cognitive Science Department at Case. And he's the co-director of the Red Hen Lab, which picture you can see there. It's not really a red hen, but it's hen with a red background. But that's still nice. He has a lot of different prizes from different foundations, among them Alexander von Humboldt Foundation, from the French Academy, Simon Guggenheim Memorial Foundation, and a few others. And he also had an external research professor at the Krasnow Institute for Advanced Study. So we are starting working with Dr. Turner in the research computing, and he's going to tell you a lot of his collaborations as well with other institutions around the world. And with that, I'd like to welcome Dr. Mark Turner.
Hi, I'm Mark Turner. I direct the Hen Lab. I'm a cognitive scientist, and I am a cyber infrastructure wannabe. There are 8 billion people on Earth, and any scene of human interaction is a scene of communication. And this has been going on for about 50,000 years. That's a ton of potential data. So any scene is, in its ecologically valid reality, highly multimodal. But we have, in linguistics, have not really had access to that data before. So what do? We study texts because we can get them. They're in a library. Now, I love texts. I love textual data, but all due respect, it is a very narrow kind of data. That is, the relationship between text and speech is very strange, very strained. It doesn't have prosody, it doesn't have intonation, it doesn't have suprasegmentals, it doesn't have eye gaze, it doesn't have gesture, it doesn't have body stance, it doesn't have viewpoint, it doesn't have the ground that we share. In other words, it does not have what human beings are evolved for. The reason you can read text and make sense of it, notice it takes children quite a while to be able to do that, is because you can supply by simulation all the things that you need in order to make sense of it. Moreover, the kinds of text we have been quite narrow, very good, but quite narrow. So maybe certain priests were interested in certain kinds of texts, and they're recorded on birch bark, and so that's what's in the library. Now, corpus linguistics has tried to expand this over the years, but it's been very slow. The other difficulty that we have is that human beings are multimodal, not just text-based. So everyone will recognize this to be true if you've ever had anything to do with a baby. So this is an example of a child that has been conditioned by iPads and intuitive gestures on touchscreens, and is trying to deal with a magazine, and consistently tries to make the magazine open and expand, right? Baby hardly even speaks. Now, everybody knows that this is the actual scene that we want to study, something like that. Real ecologically valid from all over the world. Okay, so how do you get that kind of stuff? Well, Red Hen was conceived in the early in 2000, 2001, 2002, when I was watching genomics. And in genomics, they had a common spot where all the data anybody was getting was being posted in real time. Hi, I've got this part of it. Well, no, you don't quite, because I think an R test and this, and the thing roared very quickly in like 2 years. It was incredible, the progress that genomics made. Everybody was sharing data, and it was in real time, highly collaborative, big data. I thought, you know, we really need something like that for the study of human communication. We need ecologically valid data, and we need everybody working together. Social science and humanities have not had that kind of power. Additionally, in the sciences, there are an awful lot of techniques that really leverage the human scientist. So Laplace said that when Napier invented logarithms, it effectively doubled the life of an astrophysicist, an astronomer, because now you could add instead of multiply. Well, so in the sciences, you have computational, statistical, technical resources that you can use to make big data tractable. I mean, mostly what we have done in the humanities and the social sciences is look at some data, maybe sometimes put a little statistics on it and try to pick out visualizations and so on. But that has not really penetrated to the study of multimodal communication. Now, that was the conception, looking at genomics. The birth was when I was visiting UCLA. One of my former dissertation students is a professor there, Francis Steen. And he knows my family, and he knows about quantum physics and was talking to my middle son. We were all there. My wife was there for the Los Angeles Times book fair. And he said, oh, come on, I'll show you this computer system I've just taken over. So we went into this, you know, blade server room in a data farm, and I realized that what he was doing was beginning to capture television news broadcasts digitally. And I said, no, wait, how much have you got, and so on? Well, it turns out that Section 108 of the US Copyright Act says that notwithstanding anything else in law, a library or an archive in the United States can capture audiovisual news from anywhere, broadcasts, not to share with the public, but to make them available as a research collection to actual researchers. Well, this is fabulous. The sort of, God bless the US Congress for thinking that news is actually sort of a public good, that it has to do with information and so on, and nobody really owns the news as far as research. The model here is Library of Congress. When you publish a book, you have to give a copy to the Library of Congress so that they can loan it out for research, and that model extends to this kind of stuff. And news means essentially anything where people are talking about current events. So that's interviews, you know, The View, Oprah, late night monologues from comedians, stand-up comics, things like that. Okay, now, we have a lot of people in Red Hen. We have hundreds of people in Red Hen now, lots of universities, funding from lots of places. And some of those people are interested in the news, right? Political scientists, things like that. That's not the main line. What we want to do is develop tools and systems that everybody can use. So it's all open source. Everything we develop goes on the GitHub. Everybody who works with us has to have a GitHub, post all the stuff. Tools that can be used on anything. So we can ingest any kind of video into Red Hen. That includes Disney movies. We can't share them because of intellectual property, but if you have the right to see Winnie the Pooh in the blustery day and you're in Red Hen, we can stick it inside Red Hen, run the Red Hen tools on it, and the derived products, that is all the metadata, all the tagging, all the statistics, and so on, you certainly can use and publish. We can do that with anything. We have robotic, we now have 350,000 hours of various kinds of recordings. Various archives around the world have been ingested into Red Hen. Right now we have crawlers working on art databases, bringing in the art, Roman portraiture, for example, so that we can tag that. And all of the tools we develop are always available. Red Hen is just a bunch of people like me. They're real researchers. It's not, we don't have funding for a service, but if somebody wants Red Hen, we explain it's a collaborative, it's a cooperative. You offer Red Hen something, and it's a win-win. You get everything that everybody else has developed, and you do something for us. And what you can do for us, there's a lot of that. Now, I want to give you an idea of what we're talking about.
There have been two question that's raised.
War declares media, which provide alternative views on world news. Views which often run in contrast to the coverage of events by the U.S. mainstream media.
So watch the gestures.
We have an information war, and we are losing that war. I'll be very blunt in my assessment. Al Jazeera is winning. The Chinese have opened up a global English language and multi-language television network. The Russians have opened up an English language network. I've seen it in a few countries, and it's quite instructive. We are cutting back. The BBC is cutting back.
Right? So I want you to understand, I want you to imagine 350,000 hours of that, and it comes with closed captions, or in Europe, teletext. And our sister organization that helped Red Hen get launched is called CC Extractor. CC Extractor can crack the closed captions out of the transport stream and put the perfect timestamp on the closed captions, which means now all those Unix, Linux, Starnix, utilities for search, grep, sed, awk, can go to town on the closed captions. We can unleash and have unleashed the world's natural language processing, so the Stanford NLP, Open NLP, and tag all of the closed captions, right? There are transcripts available for CNN, ABC, NBC, CBS. Somebody got a PhD for writing code that would take the closed captions and the transcript and put them into time registration. The transcripts are never quite the same as the closed captions, but good matching so that the timestamps can be inherited. So you can search the MP4, you can search the closed captions, you can search the transcripts. We unleash Google Tesseract on the on-screen text, optical character recognition. So long ago, we had figured out how to take a high-resolution snapshot of anything that's in the audio-visual stream. So talk about big data. We just said, okay, take a 1-second snapshot of everything in the archive, 350,000 hours, feed it through Tesseract, get out the on-screen text, have an algorithm for figuring out what's the best spot, the best stuff. So now when you're rendering in the search or looking at things, you can say, and I want to know what, and I want the text on the screen to be saying this kind of thing, which isn't necessarily a string because we can do NLP on the text box too, so you can look for a certain kind of grammatical construction. And of course, we can do this in any language.
Am Vorabend des Referendums ist Griechenland tief gespalten in einem Moment, in dem viele.
We're UTF-8, so we don't have any trouble with any kind of digital script. That's Greek, Cyrillic, Mandarin, doesn't matter. We can run it all in, French.
2000 personnes à Téhéran et un message très clair, mort au magazine français Charlie.
And we have some Polish. No, Czech, sorry.
Aktuálně už 171 obětí, polský Krasnodarský kraj, dál sčítáno po záplavách.
So now this is big data for comparative language. So if you happen to be a linguist and you care about different language families, if you want to know about all those Arctic languages that are endangered, that we're losing, we record Northern Sami from Norway. Now, why do we do this instead of having rational systems according to which the actual TV broadcasters keep this on their server? Why do we have to get it from the air or from terrestrial digital? Well, it's because they don't keep the closed captions. They throw it out. I spent 3 years trying to explain to people that they should give us the closed captions. They don't have them. I was in Norway for a year at the Norwegian Academy of Science and Letters. I was sponsored not by the Ministry of Education, but by the Minister of Education. I met with them, I had the letter. I said, hi, this is science. You need to keep the closed captions. They don't have it. They throw them away. right? They record them anywhere. I found one engineer that had actually kept him because he was so bothered that they were being thrown away, but he didn't have the authority to release them. I also went to Swedish. You understand, we have tens of thousands of hours of Scandinavian languages now since I went to Norway and set up a capture station, right? I went to Swedish TV in Stockholm and explained to them that, this is what we get and we'd like you to provide it. And they said, that's great, it'll cost $1,000 an hour. I said, no, you don't understand. Also, their idea of what people would want to look at is that half an hour of news showing you when Marilyn Monroe came to Stockholm, right? The idea that this is an archive of communication that you could use to understand what people are doing, develop tools, and then use those tools on all kinds of things. The news actually has a lot of different formats. Sometimes it has recordings of people who don't even know they're being recorded. It's surveillance video. Sometimes they have interviews in the field. Sometimes they have conversations with kids, but they also have news anchors, right? So they've got a lot of different kinds of things, but we can also take any other recordings that anybody has got and put them in Red Hen and use the Red Hen tools on them. This is really important for things like gesture because the gesture world, mostly what they've got are recordings in the lab, so there's a problem of ecological validity there. I mean, you go into a gesture lab, and how are you going to perform? So you'd like to check that data. But also, you're talking about maybe, 5 hours of data. And that's great stuff. You can check it and see how it goes on there, and then you can check it with out-of-sample data for another, 350,000 hours and see what's going on. So this is a bunch of Russian, for example. So what are the kinds of things that we can now do? Well, first off, this is the opposite of big data, cyber infrastructure. It used to be that we had to use satellite cards and big servers to capture the TV, right? But when I was in Oslo, I had a broken MacBook Pro, and I stuffed it, and as you know, Mac has Darwin, which is a mock Unix shell, and you could stuff it full of Mac ports and basically turn it into a Linux system. So the stuff we started capturing, and this was the first international capture station, was on this laptop, right? And so it was Mac. But then last summer, I found Raspberry Pi and demonstrated that a Raspberry Pi 2B for $40 can do everything that our big Linux servers were doing on the capture side. You just capture it, ship it to a center. So that's my finger trying to demonstrate to people that small is beautiful, that this would really work. Okay, so once you get a bunch of big data, what can you do? By the way, we have visual search engines, we have lots of things you can imagine. This crowd I don't have to educate, but let me give you an example of linguistics, okay? I work on grammatical constructions. To know a language is to know a relational network of form, meaning, pairs, and how they can combine. Some of these constructions are lexical, like dog. Some of them are fixed, like kick the bucket. Some of them are very weird, like the more the merrier. Is that a sentence? What's the verb? Is more a noun? These are the kinds of things that thrill me to research, that I think of at night. And all around the world, that's what, human communication is vastly more complicated than anybody untrained can possibly imagine. It's just incredibly difficult and complicated. What you know as masters of any language is amazing, and unless you're trained, you don't have a clue what you know. You think you do, and you'll tell everybody, but then the linguist will show, no, that's not how it works at all. So take something like the X or the wire, which is the more the merrier, right? Well, there's a researcher, Thomas Hoffmann in Germany, Red Hen, who thinks that there are gestures associated with this construction. So we've been able to work on the more the merrier as a construction, but nobody can work on the gestures associated with it, or on certain kinds of intonation contours in speech. This is very, very important because there are constructions, grammatical constructions in a language that differ only on the sound. So we say there are celebrities and then there are celebrities, and the then distinguishes. But there's a phrase in Spanish, hay cosas y cosas. There are things and things, right? And that can either be accretive, like there are stars and stars and stars, or it can be contrastive. There are stars and there are stars, right? And the only difference is the contour, the speech contour. You can't get it out of the text. Well, okay, in Red Hen, you can write a little bit of code. You can go looking. You get 39,198 matches instantaneously for the X or the wire. And moreover, it's looking, it's not looking for the more the merrier. It's looking for any form of this construction. You see how this works. You find it, and then you can instantly, from the link, this is real time. For instance, I hope this works. This is real time from LA.
Shrinking, weakening, moving to the southeast, allowing the approach of a front. The closer this front gets, the stronger the cool, moist onshore front.
So you can immediately go and look at the actual human performance. Stop that. At the actual human performance of what you found. And you can, 40,000 examples. Export all of your hits into a comma-separated value file where you've done certain kinds of searches, and you can say, I want this with that kind of blah, 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 blah. The comma-separated value file can be thrown into R, and you can do your visualizations and so on. Now, we have, I'm gonna sort of cut to the chase and say, we've had 2 Google Summer of Codes. So here comes in, I bring all of this linguistics and cognitive science and brains and language and multimodal communication analysis to application programming, where we use all kinds of tools and invent tools of the sort that you know, for search, for tagging and things like that. But now what we want to do is actually go after tagging the audio and the video. Now that is CPU intensive, and we in Red Hen are not efficiency programmers. We're not efficiency coders. We don't know how to run things in an efficient sort of way. Last summer of code, we made an audio detection pipeline. You can go, by the way, to Red Hen Lab. It'll come up immediately. And what you will see is lots of things that we are working on. We have a project in Roman sculpture for tagging for wrinkles, age, and authority. We have blended classic joint attention. Blended classic joint, when you and I are talking and we're right there together, and that's what we're evolved for. But that's classic joint attention. But blended classic joint attention is when you're using classic joint attention to try to understand something that's not. So a personal letter isn't actually classic joint attention. You can't ask somebody to clarify what they said in the letter. They're not there. You don't share the same ground. But you use the idea that you're talking to somebody or they're talking to you as a way of making sense of this letter. It's blended. So the idea of classic joint attention is blended with other things. Here, for example, you know in the news that these people are actually talking to each other, although they're in different places. Now, in the real world, if 2 people are facing in the same direction and are side by side, it means they can't see each other. This is a new construction for media. Very interesting. If they're looking out of the screen, it means they can see each other. You know that instantly, despite the fact that you've had no experience with that in classic joint attention. So we're looking at lots and lots of data on blended classic joint attention and Red Hen tweets. You can see this kind of stuff. So here's one, to give you an idea of the kind of interest. There's a gesture here. Some people are interested in these recordings to pick out things that you would find in classic joint attention. So this woman is about to say, and if you need help moving your data from your old hard disk to your new hard disk, and that head tilt where the older one is on the left, That's very, very standard. But she's also at the end going to do something very different. She's going to say right there and point to and look at something that in fact she can't see, but she knows you can see. This is blended classic joint attention. The reason I run this one is you can see it. It's playful. You can see what's going on. Mostly when this is happening in media, you don't realize it's going on because you've already got those constructions. So let's have a quick look at that.
If you have any questions about getting the data from your old hard drive to your new hard drive, we made a video for you that covers the process, and we'll link to it right there.
And it says here, up there, right? Okay. So you can look at all these things. Last summer, we ran Summer of Code. We had 8 students, plus we paid for a bunch more. And what they did was audio detection, things like forced alignment, because the closed captions are at a lag. I could explain why. Not much of a lag, but using a sound pattern for the language and natural language processing, you can force the alignment. So when you search for the utterance, you can get just exactly the moment when that person is saying it, and look at the lips, look at the eyes, do facial detection, things like that, have it all line up. Other people who did things like on tagging for paralinguistics. So there's an awful lot of communication that doesn't show up in text at all. It's like a sigh, tapping things, laughing, various kinds of they're meaningful, they're very communicative. So this person wrote code for tagging, that kind of thing. Speaker diarization, so you can say, oh, that's person A, that's person B, that's person A, that's person C, that's person A, that's person D, right? Audio fingerprinting, music, segmentation, knowing when there's a shift in the media. But we want to make a pipeline and tag 350,000 hours of video with all this metadata. Well, we don't know how to do that, so we have come to Case HPC and said, hi, you have CPUs and GPUs, and can we put together a pipeline and actually do something very huge? And not as a sandbox, so we can play with it and then publish it in a paper 5 years from now. No, so that we can tag the whole data set, so we can tag the extra 150 hours of recording that comes in daily, just robotically. And then there it is for remember the genomics? And then there it is for any red hen to go looking at and so on. Last bit, we have a Google Summer of Code for this summer. This is the last thing I'll say. And this time what we're working on is visual, gesture, and machine learning. So we have to make a training set, and we have developed systems using Elan and other kinds of existing open source. Everything we do is open source, as I said, open source software, collaborating with the developers of Elan, to make training sets that then can be fed to these deep neural net preparers of classifiers. We have our first 2. One is a classifier that picks out timeline gestures. So somebody says, well, from inception to completion, how long did that take you? You can find those by looking for the text, but you might not know the text to look for. So we want to do the other direction, tag the gestures, and then see for those gestures what people are saying when they make those gestures or things like that. Another one is, this was brilliant. Sergey Turkin, working with Professor Shumia Ray here, produced a no gesture detector to be used interactively. So it goes through the video and says, no, there's no this is a speeding car. There's no gesture here, right? This is a view of the sky. There's no gesture here. So the tagger, the manual tagger who's looking for things, gets help from the classifier, telling them where to go looking, and here's our confidence, and so on. And again, for these gestures, for Roman portraiture, for medieval art, for picking out Christian iconography. So this really isn't dedicated to the news. It can do anything that we can throw into Red Hen. When we do this, we want to make another pipeline, And we, as I said, I'm a cyber infrastructure wannabe. Now what we need to do is move into efficiency computing and figure out how to move around from all our different centers, all of this data, do the tagging, move it back, do it in a dynamically efficient way. And I'm very grateful to the CASE HPC system for helping us in that, and I'm very much looking forward to learning about other kinds of cyber infrastructure that might really penetrate and provide new tools for the social sciences and the humanities. Thank you.